Oh, the Transformers. Takes me back. Decepticons. Optimus Prime. Oh my goodness. Bumblebee. All right, anyway, so yeah, there's good movies out there, right? The cool thing about those movies is they take place in Chicago, so a lot of action's happening in Chicago. You can actually go to those locations where buildings were destroyed and that kind of stuff. But anyway, obviously just a movie. So all right, let's focus here. We got lesson number 7 that we are working with here. What we are after is the continuation of being able to set up our equations to solve. The reason why we're really focusing in on setting up our equations is because we don't want to get involved with guess and check. Guess and check is not an efficient technique. I mean, it saves ourselves sometimes, but it's not something we want to pursue there. So, all right, you got your brother here heading off to college. So you no longer have to share a bedroom. All right, you decide to redecorate a wall by hanging 2 new posters on the wall. All right, the wall is 14 feet wide. All right, and each poster is 4 feet wide. You want to place the poster on the wall so the distance from the edge of the poster to the nearest edge of the wall is the same distance between the posters, is in the picture below. Okay, and this is something there for it there. We hang picture frames in our house there. I know you think in your room, just slap the poster up there. But if you're putting it somewhere prominent there, you do want it to be balanced here. So, the main thing here is we want to be able to set up an equation to solve for it rather than just using guess and check. All right, your ability to set up an equation. So we know that we have an entire distance of 14 feet. All right. We also know that we've used up 4 feet here, and we've also used up 4 feet here. Now, the thing is we don't know the distance that's in between. All right. So we need to calculate what that distance is going to be. Now, what we do know is it's all the same. So if we don't know the distances, but we know, we'll call it x. But we know this is the exact same amount. So we know that's x. And we know this is the exact same amount. So that's why we're calling it x as well. So we can set up our equation here. The entire distance is 14 feet. So we know it's going to equal 14. All right. We've got an x and then plus a 4 and then plus an x plus a 4 and then plus an x would result in that entire distance of 14 feet. So let's clean things up a little bit. X plus x plus x, 3x, 4 plus 4, that's an 8. Now, for some of you, you might have already, you didn't even write this out. You just jumped right to 3x plus 8. And that's fine. There's nothing wrong with that at all. If you see that, hey, go after it there. So if we subtract 8 from both sides, all right, we get 8. 3x equals 8, so we're going to divide both sides by 3. So we can say 8/3. The thing about this is we want to know specifically here, so I'm going to actually simplify here so we have a more realistic answer. We can take out 2 and 1/3. All right, feet. So if I'm using a tape measure, all right, it's going to have feet and inches. How many inches is a third? Well, if there's 12 inches make up a foot, I want a third of it. Yeah, it's 4. So I would take that as an answer. It is 2 feet and then 4 inches as well. Now, and this is the reason why we like the equation, is because we might not always get something neat and clean, and we just don't want to continue to guess and check over and over again. So all right, so let's head on down. All right, let's see what we've got here for your next problem. Ooh, all right. Your parents are redecorating the dining room now. Want to place a rectangular wall sconce lights. All right, so these are just lights that are actually on the wall. They're not suspended from the ceiling there. All right, a lot of times they look like candles. Very nice. All right, and they're 25 inches wide along a 10-foot, 8-inch wall. So the distance between the lights and the distances from each light, the nearest edge of the wall are all the same. Okay, so we've seen this before. Now, what's interesting about this particular problem is our units of measurement. Yeah, I know I'm not happy about it either there. We're in feet here, we're in inches. So we want to get everything into the same units of measurements. I'm more of a fan of using the smaller units of measurements. That way I've got whole numbers and I don't have lots of fractions that I'm using. So I'm going to convert everything into inches. So I'm already in inches, 10 and 2/3 feet, I need that. So, okay, so 10 and 2/3. Okay, well, things we can go about. Okay, so let's worry about the 10 feet first. 10 feet is actually going to be how many inches? Well, 12 inches in a foot, so I got 10 of them. Oh, so that's 120. Okay, and then we want 2/3 of a foot. So 2/3 of a foot. All right, so 2/3 of 12 if you want to go mathematical here, what does the word of mean? Of means to, yeah, multiply. So you could do 2/3. You could times it by your 12. Oh my goodness, cross division. And so yeah, it's 8 inches. Now again, some of you can visually do that. That's fine. There's nothing wrong with that. So I know my entire distance is 128 inches that we are after. Okay, so very similar from before. I don't know the distance. I'll call it x. All right. So I know it has to equal 128 inches. All right. So I know x plus x is 3x. 25 plus 25, there's 50. And oh my goodness, what a beautiful equation I've got there. All right. Let's go ahead and solve there. Let's go and solve. Did you subtract 50 from both sides? Absolutely. 3x equals, and when you subtract, what do you get there? When you get there, how about like a 78 maybe? All right. So let's divide both sides by 3. All right. And again, if we reach for our calculator here, nothing wrong with that. 2 times 18, 26. Yeah, 26 inches. So we know we're at 26. And again, if I want to check to make sure, plugging on in, 26 times 3, add my 50 onto that, I should get my 128. So yeah, so 26 inches apart for each of them there. Watch, make sure you are kind of labeling answers. All right, ooh, and I should box mine in there. All right, I'll go to 2 1/3, that's there. There we go. So again, your ability to set an equation is definitely going to kind of help you out there. Now, this is kind of walking you through it. So I'm just going to kind of, all right, we're going to just kind of move on down here. All right. And let's go after example number 1 here. All right, the ages of 3 sisters are consecutive integers. Now, the big thing about consecutive integers is knowing what it means. Well, what does consecutive mean? All right, consecutive means in order there. So like 1, 2, 3, 4, 5. Yeah, those are all consecutive integers. I'm not bouncing around at all. All right.
Cool story, bro.
Well, just trying to explain what a consecutive integer is. Okay. But we know it has to, the sum, sum means has to add up to, and then we do need 45. Okay, so the big thing here is being able to write out your equation. So the youngest sister, we don't know how old she is, so we're going to call her X. All right. What would the next sister's age be? Well, what would you do to X to get to the next number? Think about it. If it was 1 year old, what would you do to get to the next number? Well, you would add 1 onto it. So the next girl would have to be X plus 1. All right. Now, again, we always want to go back and I kind of work off the original. Okay. So the third sister here, if it was 1, but I want the next number, what do you do to the 1 to get to the 3? Well, you would add 2 onto it there. So there are my expressions that we've got that represent each of the girls' age. Now, if we kind of think about what we got going on here, all right, and I'm not, they're trying to walk you through it there, so we're just going to go straight to the solving here because we're ready to do that. We know that if we add the sisters up, so if I take the one sister, add it to the other sister, add it to the third sister, I know I should be getting 45. Okay, what are we calling the first sister? We're calling her age as X. Plus, what are we calling the second one? Well, we're calling her X plus 1. And then we're calling the third one, well, we're calling it X plus 2. All right, again, we're trying to stay away from the guess and check because, again, it's just not efficient. We're doing it with numbers you could probably guess and check with just because we care about you and we just don't want to, make things off there. Oh, and the crowd roars for that. Okay, all right. Well, let's solve. Let's solve here. Add your x's up, 3x. 1 plus 2, yeah, 3. And now we're going to solve our equation that we've got going on there. All right, subtracting 3 from both sides. 3x equals 42. Divide both sides by 3. I'm running out of room here. I got a little bit down there. X equals, oops. How about a 1 there? And how about a 4 there? You buying 14? All right. Now, this is where we gotta be careful because we do actually need to make sure that we solve the problem here. All right. The one girl is 14. The next girl is, add 1 onto it. Yep, 15. And then the third, yep, 15. So they are 14, 15, and 16 years old. So that's going to be one of the big things here is making sure that you're actually answering the question that they're asking you for. All right. Let's see here. I'm trying to think of what I like about this particular one. All right, so here's what we like about there is we're going to jump on down to question B here. All right, we're just going to kind of skip this part right there. We got Sophia here. She pays $19.99 membership fee to an online music store. So every single, well, it's just a fee. It doesn't tell me it's a monthly fee. So she's paying it there. All right. If Sophia purchases N songs for 99 cents each, write an expression for the total cost. Okay, so important things here. First of all, it's saying write an expression, not an equation. Okay, not an equation. So I'm not going to be able to solve for this here. They're just kind of getting an idea of like, listen, how much would it cost her? Well, okay, she's got to pay for two things. She's got to pay for the membership. All right, and the other thing she's got to pay for is the songs. So to find the total cost, you would add the two together. Well, how much is the membership? Well, it's $19.99. All right. How much is each song? Well, okay, it's 99 cents, but how many songs did she get? I don't know how many. And again, you've seen that theme here. When we don't know what something is, that's when we give it, all right, that variable, we use that particular letter that we're after. So 99 n. 99 cents times n, therefore they're 99 hundredths. Yeah, exactly. So again, it is just an expression. There's my expression there. Now, what we want to lead into is question number C here. Question, letter C. All right. That would be the answer to can I speak today? Okay, so Sophia's friend has saved $118, but isn't sure how many songs she can afford if she buys the membership and some songs. So use the expression in part B to write an equation that can determine how many songs Sophia's friend can buy. Okay, so this is how much it's going to cost. She has a total of $118. And again, hopefully you're starting to see that theme of what you have as a total amount. We got a total of $118. It's going to cost the $19.99 plus the 99 cents for each song. So let's do a little solving of an equation here. All right. And again, this is kind of where you can break out the calculator if you would like. I certainly would understand that. I'm going to use a little estimation. I'm going to pretend that's $20. So if I subtract my $20 away, that would give me 98, but I do have to add the 1 cent back on because again I did take the extra cent, so I do need to subtract it away. So $98 and 1 cent is what you got. So we're going to divide both sides by 99 cents. Now again, this is where, hey, calculator wise, I think we've kind of reached our limit on it. I'm going to plug that in there, 98.01. I'm going to divide that by the 99 cents, and see, now I'm a little bit disappointed. I'm a little bit disappointed here because it's a whole number, and I'm trying to figure out how on earth I did not figure that out. And if I think about it, times it by 100, that gets me $99. Oh, one away, man. I'm sorry if I've disappointed you today with my lack of mental math that I displayed on there. All right.
I like turtles.
You know what? You can like turtles all you want. It's not making me feel better right now. Okay, so she can buy 99 songs. Listen, people, I'm gonna go ahead and just kind of cry myself to sleep here. I'm gonna kind of just let you go here, and yeah, we're done for today.